Chemical bonding, structure and properties. Bonding, when we say bond, the word bond means a relationship, the bond between friends. Chemical bonding, basically, it is an attractive force that holds the atoms together. Holds the atoms together. I mean, it's an attractive force. Fine. Why atoms bond? Why they never stay alone? They bond to complete their valence shell, like noble gases. I mean, they want to make their last shell like noble gas. Helium, neon, argon, krypton, xenon, radon, noble, inert, they never react. They are in the air. You'll not find their compounds. Very rare. And those compounds are complex compounds, not normal bonding way. Because they have complete valence shell, complete outermost shell. Suppose if it is helium, it has only 2 electrons and they are placed in the first shell. You know from the atomic structure that the first shell maximum 2 electrons. So many bond like hydrogen, like lithium, like beryllium to complete their valence shell like helium. They want to keep their one shell as the last shell, first shell as the last shell, like helium they become, we call that as duplet rule. But many other, since has more than one shells, they want to be like other noble gases. They have 8 electrons in their last shell, like neon, argon, krypton, whatever. So bonding may be an attempt to complete their valence shell, and in doing so, they turn into molecules, they turn into ionic compounds, they turn into covalent compounds, they turn into macromolecules, or whatever, and we have variety of chemical compounds and variety of chemical properties. We have a variety of things around, the synthetic material naturally occurring. Noble gases, they are inert, they are used as such, like in weather balloons or in bulbs, but they are limited uses. Chemical compounds from hydrogen, from carbon are numerous, millions in number, because they are on incomplete last shell, the vacancy, and they can complete their valence shell. In doing so, chemists exploit that, and they can. Keeping things simple, bonding is an attractive force that atoms actually hold the atoms together. And atoms bond to complete their valence shell like noble gases. Chemical bonding types in your syllabus: ionic, covalent, metallic. Covalent, simple covalent molecules, larger like diamond, graphite, silicon oxide, silicon carbide, and coordinate covalent, a special type of covalent bonding, dative bonding as well, kind of special covalent bond molecule, like in carbon monoxide. When we say ionic, the word ionic means ions, positive ions and negative ions. An electrostatic force of attraction between oppositely charged ions is called ionic bonding. Look at positive ion and negative ion. Since bond mean attractive force, and this attractive force is very much obvious here in ionic bonding. Electrostatic force of attraction, an electrostatic force of attraction between what? Oppositely charged ions. Look at that, sodium and chloride, sodium positive, chloride negative, or this is sodium ethoxide, or it may be ammonium chloride. So how normally a typical ionic bond is formed? A typical ionic bond is formed by complete transfer of electrons from metals to non-metals. Metals completely transfer electron to gain a noble gas like status, and non-metals accept electron to gain a noble gas like status. Okay, in doing so they turn into positive ion and negative ion, and positive ion and negative ion are stuck, bonded for life by what? The electrostatic force of attraction, and they turn into a formula unit or an ionic compound. Simplest example can be of table salt, the rock salt, the most common salt, has of course the flavoring agent, the main use. It's also a source of sodium metal used in lamps to provide the yellow glow. A source maybe of chlorine, rather it is aqueous sodium chloride is electrolyzed to get chlorine. Chlorine is used numerous ways, especially as a disinfectant, as a germicide. But imagine what it is. It is a chemical reaction between sodium metal and chlorine gas. Take sodium metal, heat it with chlorine, you will have lump of table salt. Although independently alone sodium is an explosive metal, with cold water it catches fire, and chlorine is a poisonous stuff. but their chemical reaction, which is a result of a ionic bond, produce what? Sodium chloride. Let's see how it happens. I said they do so to complete their valence shell. Check sodium, atomic number 11. You have the periodic table. 281 is the configure thing. The one thing, the last electron, 1, it has to release it. So it turns to 28. Look at one electron being given off and turns 28, sodium ion, 1 plus, stable ion. Why stable? Like neon it is, 28, isoelectronic with neon. And chlorine, 287 in atomic form, but accepting the electron from sodium metal when they are heated together, it is sodium chloride. Chloride ion, 288, like argon. Nature has prepared, of course, infinite amount of sodium chloride for us, because this preparation would have been very tough, but experimentally you do so. Now look at the formula formed, formula unit when the examiner asks. Sodium ion, chloride ion, swap the valencies, NaCl. Check out. Na 1 plus, chloride 1 minus, swap, you get what? NaCl. And examiner also wants us to draw a dot and cross diagram. Electrons of one atom by dot, one ion by dot, another by cross. Sodium chloride. Look at the sodium ion, 2 and 8 stable. I copied it from there, 1 plus. And chloride ion, 288, 1 minus. Complete shells are shown in this case. Sometimes the examiner may ask only show the last shell. So the outermost shell is shown. But look at the stability. Square bracket is compulsory to show the charge density. 1 plus, look at, not plus 1. Chloride 288. One of the electron is shown with cross. That is gifted from sodium. Chloride ion 1 minus. And we have what? Sodium ion, chloride ion locked in what force? Electrostatic force of attraction. The ionic bond, the ionic compound. Another example may be magnesium oxide. So a strong ionic compound used as a refractory material, we'll discuss, making ceramics. Magnesium 12, 282. 2 is the uncomfortable thing for it, loses it when it heated with oxygen in air. And these two electrons are accepted by oxygen with things. It turns to 28 like neon. It turns to 28 like neon. But one is positive ion, other is negative ion. They are locked in a relationship. Electrostatic force of attraction between these two much stronger than NaCl. So it melts at 4000 around, reason strong ionic compound. Magnesium oxide, dot and cross. Two crosses are shown that magnesium has gifted these electrons. Complete transfer of electron, the ionic bond.